Hello guys, back again with the next video. And on this in this video I said we would be rendering the texture onto the quad. So that's what we'll be doing. Let's just go about doing that. So first thing I want to do is there is a little thing I forgot to do. In the window.h, remember in window.cpp, sorry. Remember we did in the window procedure I said we want to handle size specifically. I never did get to do what we were supposed to do, so let's just do it now. So actually, let me show you what happens when we don't handle it. So let's just run. So as you can see, when we resize this window, something weird is going to happen. As you can see, the rectangle is now cut off because when OpenGL starts, it really just assumes the size will, well, not assumes, it doesn't know that the size of the window has changed, and it will just render using the previous dimensions of the window. So what we actually need to do is tell it that the window has changed in dimensions. So let's just go about doing that. So how we're going to do that is just we're going to declare something called a rec. This is a window specific thing, nothing to do with OpenGL. And we're just going to call it window size. You could initialize it to 0 if you want to. Doesn't matter. And then what we want to do is just get window rec. Yeah, this thing here called get window rec. It takes in the window. We are calling it window handle, I think. Let's just go check. Yeah, we are just calling it window actually. And next it takes in the rec we want to store the information in. It takes it in by pointer, so just store window rec, window size, sorry. And it returns a bool. We can check here. I don't really care about checking it, but at the very least what we'll do is if it does return true, then we'll just print f. I'm using the ternary operator, the question mark. We'll just print f the size, the new size that we got, x. So x %d and y %d. And the way how and this returns, and the way how it does is the window rec contains. Let me just show you window size. Oh yeah, by the way, when we are creating a variable inside a switch statement, we have to put it in the scope for some reason. That's another weird thing about C++. So yeah, I don't know if that is why I'm not getting the autocomplete. I'm still not getting it, but basically it contains something called the left, the right, the top, and the bottom. So basically the way how you would get the size of the window, the width and the height, you'll basically subtract the left from the right. So so let me just show you window size dot right minus window size dot left. Okay, and to get the height, you would just do window size dot bottom minus window size dot top. Okay, and that should be fine. And because we're using the ternary operator, we just have to return something in the case it's not true. I don't know, we could just like return minus, well, yeah, we could just return, I guess, -1. Well, actually, that just printf get window ret field. It really shouldn't, only if you pass in a wrong window handle or something, or but yeah, we'll just get window ret field. You really don't expect that to ever error out. Okay, so that's it. And you know, instead of calling this x and y, let's just call this width and height. Okay, so after that, what we'll do next, we have to set the we now have to set the actual viewport, so the GL viewport. So this is something that is specific to OpenGL. Now the first two parameters are the x and y. We just want to pass 0 for those. Those are the similar to the starting position of the window, not necessarily the width of it or anything like that. So we just want to pass 0 for both of those. Now we want to do the same thing we did here to figure out the width. So left minus right. I'm not going to store it in a variable because I mean we're never going to use it anywhere else in here. I barely use it for this printf just because. Okay, and that's it. So we should know it shouldn't do that weird thing where it cuts off the image if it resizes. So let's see. What happened here? Windows should be here. Oh no, sorry guys. We actually have to use the window handle that is passed in right here. I forgot. It's actually not it's the same window handle, but it's just not the one that you can't use the class. Because remember, this is actually not part of the class. This is just a function, that a random function somewhere. So you actually have to use handle itself. Okay, so that should be it. So now let's resize the window, and we should get the printf as well. As you can see, it now properly resizes the GL viewport as well. So that's just what I wanted to fix first. Okay, so next we'll actually get to doing stuff with the texture. First thing we want to do is just load the texture. We could do this anywhere really. I think I'm just going to do this at the top. We just want to load the image we're going to use. The image I'm going to use is this this Instagram PNG right here. You could use anything really, but this is what I choose to use. It's the image I had on hand. So okay, let's get started. I would also suggest maybe use PNGs as well. Again, this is not the purpose of this application. You really, as I said, you want to set up kind of a Skype clone. So PNGs are not really necessary. You won't really need an alpha channel, but you do actually have to set up OpenGL with telling it whether you're going to be using alpha or not. So that's why I recommend that. So let's just get started. So first, let's just load the image. So the weird thing about OpenGL, I think it expects the image in a different way than we give it. So you actually have to set it to flip it vertically. So stb set flip set flip vertically on load. And we're just going to pass through because we don't want it to do that. Next, we're just going to create a couple variables to store these things above here. So they're going to be ints. We're going to store the width, the height of the image, and the amount of channels, which should be 4 for our PNG. But okay. So the next thing we want to do is just actually load the image. For that, we'll create an unsigned char, unsigned char pointer. Remember, an image is basically just an array of pixels, and each pixel ranges from either 0 to 1 or 0 to 255. I'm not too sure which one it is exactly, but either of those could be stored in a char. So we don't really need a full int or anything. So let's just go. So equal stbi load, and we're just going to pass in the path to the image. The problem with this is that the image might not be in the directory that we want. I'm just going to place this image in the bin folder and then put it in debug. So that's going to fix that problem. Of course, we could make it so that the exe is generated in the root directory itself, but I don't worry about that right now. So we can just do /instagram.png, and it also takes in, well, it will take in the variables to store the width. It will actually set the width for us. It will take in what to store the height, and you have to pass this by memory address, because what this will do is actually store the height for us. It will give us the height. And next we have to also pass the channels, the memory address of the channels. So yeah, I think this is the amount of channels you want it to have. So you could pass 4 here for RGBA. I actually will pass 4 because I do want it to have those. I think if you pass 0, it will just give you how much the image actually has. So if you're using a JPEG, it might only be 3, but we want to make it 4. Next, we will actually go about setting the texture, the OpenGL stuff. So this is not specific to OpenGL in any way, but no, we're actually going to do the OpenGL stuff. Let's just check if the image has been loaded. So f image, this is just a pointer. So if it didn't load successfully, it will be set to null. Printf image load fail. So yeah, image. Okay, so I don't want to do anything else there. Okay, so let's go to the OpenGL texture stuff. So let's just go on here where we initialize glue. First thing first, we just want to set up the texture coordinates. It's going to be another float array. Text coords. I'm not going to type out the full width. The way how texture coordinates work, they're not normalized like the vertices. So they don't go from -1 to +1. They go from 0 to 1 instead. So basically over here, this would be 1 0. It's 1 on the, well, it would be 0 1 actually. It's 0 on the y, on the x-axis, and 1 on the y-axis. Over here would be 1 1. Down here 1 0, and over here would be 0 0. But anyway, yeah, so that's what we'll be doing. So let's start 0 0. Next we're just gonna do 0 1 0. And then next we're gonna do the case where they're both 1. And next we're gonna do 0 1. Okay, so that should be it. Now we actually have to generate the texture. We could do this under here where we generated the vertex buffer. Doesn't really matter, but just to have some little order. So as usual, we just have to create something to store the texture. To store the texture object, we'll just call this text object, or we'll just call it text for now. Don't really need anything more. So we'll just GL gen textures. We want to generate one of them, and then we'll store it in text, in the memory address of text. Okay. And then we'll also, there is in OpenGL, there is the idea of like texture slots. So you can have more than one texture bound at the same time. We won't really need that, but we'll still have to set it. So you can do GL active texture, and we'll set it to GL texture 0. If you do plan on using more than one texture, you could use GL texture 0 plus the slot that you want to use. That's a little thing I learned from Cherno, the Cherno channel. Very good channel, by the way. You could check it out. But yeah, we'll only be using one texture. So that's that. Then we want to bind the texture, GL bind texture. And just GL texture 2D. The target will be GL texture 2D. It's a 2D texture. Okay, and then next we want it to send the actual texture we want to bind. So text. Okay, so that's that. So there's a couple properties we have to set on the texture. So let's just go about doing that. So there's one GL text parameter. So GL text parameter I, this is the one we want to set. And target is GL texture 2D again. And the one we want to set is one called we want to set the texture wrap. This basically it basically specifies whether we want this texture to repeat or anything like that. So you actually have to set two things: the texture wrap, GL texture wrap S. It's just a different coordinate system really. So the S, I can't remember exactly which one the S is, but it might be the X axis. GL, and we want to define it to GL clamp to border. And we have to also do the same thing for the texture wrap T. And just do the same thing, GL clamp to border. Then next we actually want to set the border color, which we'll set to transparent. So first let's just make the color transparent. We actually have to create the float of, we'll call it border color. And it's just going to be 0 all around. Okay, so that should be transparent. And just let's do GL text parameter FV. So what you're noticing how it goes, like these texture parameters are ints, and so the I on the end of here stands for int, and the one where we're doing it's going to be a float, a vector of floats, more specifically array. So you use FV. So that's the naming scheme it seems. So again, GL texture 2D. Next, the GL will tell it what we are setting. GL texture border color. And we'll actually set it to the float that we just created. So the color we just created, so border color. Okay, and that's it. Okay, so next we just want to set up the filtering. So what filtering really is in OpenGL there's a problem where, let's say this image, this Instagram PNG, it has a set size 1000 by 1000. But what if we have the image, the quad that we're rendering actually takes up more than 1000 pixels? Well, then we have a problem because the image, the texture should take up the entire quad, but if it's more than 1000 pixels, then we kind of might miss some information. So this is where filtering comes in, and we actually have to set the type of filtering you want because there are many types. So what we'll use is most likely linear filtering. There's also a nearest neighbor, but it might not be a good fit for this type of application. Linear is better for use when you're filtering like true realistic kind of images, like an image of a person or plants or something like that. So that's what we'll use. So the way how we set out is just GL text. Again, GL text parameter. And we use I. GL texture 2D. Next, we'll tell it which one we want to do, because there are two cases you need to handle. One where it's magnified, and the other case when it's minified. So we just handle the magnification filter first. GL texture mag filter, and we'll set it to GL linear. Okay, and we'll also do the same thing for the min filter. Maybe nearest. It doesn't really matter actually, but now let's also do linear and see. We'll see how it looks, but you know, we might not even need this because it might never move away from the camera. So, but we'll still do it. So that is what this is the entire setup for the texture on OpenGL. So all we actually have to do now is load the texture onto the graphics card. So the way how we do that. So if the image did load successfully, then we don't have to worry. It's going to be in memory. So we already checked that above. So let's just go straight into doing it. So in order to buffer the texture onto the GPU, we have a function called GLText image 2D, and basically it takes the target, which will be GL texture 2D. Next, it takes the level. I think this is the map level. We could just pass 0 here. I never really use that. The format of the image will be RGBA, GL RGBA. So the width is what we will. The width is the thing we set up here. So the STBI will actually give us the height of the image, the width and height. So height, and this other one, we may not want a border actually. So the border, so yeah, we're just gonna set 0 here, and then the format of the data itself, which will just be an unsigned byte, GL unsigned byte, which is an unsigned char really. And then the actual, well, no, this is actually supposed to be the format right here. So let's just go here, create. So the format will be again RGBA. And lastly, we actually taking the image we want to do, the pixels. So we call it image. And that's pretty much it for this. We're not going to be generating maps or anything. So what we actually need to do now is actually write the shaders for this. As I said in the last video, shaders would have taken a while to do in that video, so I'm just going to do it now. So a little about shaders. A shader is literally just a program that runs on the GPU. So, and it's very much like C as well. So we actually have to go through the steps of writing the code for the program, and then compiling it, and then linking it together. So you'll see what I mean. So what I like to do is let's just create a new file called shaders.h. And we'll create a new folder called shaders. And inside here is where we'll create shaders.h. And we'll include it in all builds. Okay, so in here is where we'll actually define shaders. You can choose to write shaders either in a separate file entirely, or in the C itself. I prefer to write it in C++. So first we're just gonna define a static const char, actually const char pointer. And guys, if you are planning to write it in traditional way with strings and stuff, it's going to be very, very, very hard to do. It's going to be very frustrating as well. So what I choose to do is use raw strings. So just place a capital R at the beginning right here. and then open quotes, and then put everything inside of this thing right here. And you could put a little thing here at the end so you could know where it ends. And this will create a raw string we can actually use. So basically what this does for us is let us format the string the way we want it. We don't have to use the new line character or anything like that. So yeah, let's just get started. So to use shader, basically in shaders what we do, we first declare the version we're using, #version. Remember we are using 3.3, so we use 330, and that's that. Next we want, remember the layout we did. Oh yeah, by the way, this is the vertex shader, sorry about that. There's also something called a fragment shader. So remember in the last video where we set up the buffer, the vertex buffer, and we did this attribute thing, and we did an index of 0. So that's where this index node comes in here. So let's do layout location equals, in parentheses actually, location equals 0. And the way how we do this is we have to do in vet. It's a vector 2 actually. So yeah, in vet 2. And we have to give it a name. We're just gonna call it vertex. So next that's really all actually. Well, not other string. Don't put the quotes around. Sorry, I forgot we are using raw strings now. So next we just actually have to do the function, the void. Again, it's a lot like C, so void main. And then here we're just gonna do GL underscore position. And this has to be a capital P, by the way. I think that's a very bad naming convention. They're using underscores and still camel case, which is not a good combination at all. So GL position must be a vet4. But as you can see, we're taking in the vet2. So what we actually need to do is just convert it to a vet4. So what we'll do is create a vet4, passing the vertex, which is a vet2, and then add the other two right here, which we can just set to 0. You can just set to both to 1 actually. Yeah, that's what we'll do. And then that's pretty much it for this fragment shader, for the vertex shader. And then we'll also create a fragment shader. I'm just gonna copy it because some of the things are the same. There's actually not that much is the same. I shouldn't have to copy it. So what we'll do now is just define the output. So just do out color. So basically, unlike the vertex shader, where we have something called GL position, which will be the actual vertices. In the fragment shader, since it's the last shader in the pipeline, we just have to define the output variable, and then we could use that here. So what we're going to do just in the beginning is set all of the pixels to red, or any other color actually. I'm going to set it to yellow actually. So yellow is usually 1 1 0, and the alpha will be 1. I think that's yellow. And that's basically it for the shaders. Shaders can get much more complicated than this, but yeah, this is basically just to show you guys. And then we also in here we have to come back in here and fix it so it could display the texture, but we'll do that later. Okay, so next we need to do, what we actually need to do is set up the texture coordinates. I totally forgot to do that. So GL, so basically same thing as this code right here. GLGen buffers. And let's go declare a variable to store the texture buffer as well. So up here we should have something called TBO. There's something called a TBO which is kind of separate, but we won't be using it in this program, so We don't have to worry about naming conflicts. So that's the texture buffer object. And in here, instead of VBO, let's do TBO. Let's also just do some separation between these things because it looks kind of confusing. Just do TBO right here. And VBO right here. And again, use TBO here. And then instead of that, let's use the size of the text coordinates. Then use text coordinates themselves. GL static draw, and now instead of enabling index 0, we'll do index 1. Okay. And it is 2. Everything else seems correct. Yeah, so it's 2. It's 2 points per vertex. The texture is 2D. So yeah, everything else is correct. So that's all we really needed to do there. Let's also separate this part right here, because again, it just looks kind of confusing to me. So okay. So now that we have that, we also need to take that into the vertex shader. Well, not into the vertex shader, into the into the vertex shader, sorry. So similar to what we did here, we also have to do another layout location. And in this, and again, we chose index 1, so it's location 1. And we're going to call it text coord. We aren't going to use it yet. I just want to set all the colors to red first, to yellow, sorry. But we'll just set it up right here so we don't have to worry about it later. Okay, so this looks good for now. So now we actually have to go about compiling the shaders and linking them. This part here can get a little complicated, but we'll get through it. So where do we want to do this? I think we want to do this above even where we generate the buffers, because shaders, like a lot of this texture stuff, a part of the texture stuff we have to do later on depends on having the shader already compiled and running, already compiled and linked. So I think we should just do the shader even above all of this stuff. So yeah, right above here we define the arrays, the texture coord array. I think I'm just gonna start doing the shader stuff. So again, so just add the thing here. Okay, so right here we're gonna start. So the first thing we have to do is just store the shader. We have to create an int to store the shader, to store the shaders themselves. So again, let's do that here. We need one to store the vertex shader, and we need one to store the fragment shader. Okay, and those are what we'll use. So what we use is a function called GLGet shaders. And it just takes any type of shader we want to use. We'll use the we'll do the vertex shader first. And instead of taking in the variable, this actually returns something for us to use. So we can just use the vertex shader variable here. It returns something instead. Okay, so these are the steps we need to take to compile and link up shader. So next, we actually have to give it the source. So GL shader source. And also let's include shaders.h. I forgot to include it. So we're just passing the TXT shader. We are using vertex shader. This is what I mean by the way. It takes in the handle to the shader, sorry. Next, we'll take in the it takes in how many we want to do. We just want to do one. And next, it will take in the actual shader itself. It takes the memory address of the pointer itself. So it's kind of weird, but yeah, that's what it does. So we called it Vertex shader source. Okay, so that's that. Next it takes in the length. We could use str length. So we have to include string.h. Actually, for the length, it seems you could pass in. It seems you could pass in null, and it will just figure out the size itself. So I'm gonna see how it works. And then next, all we want to do is compile this shader. So GL compile shader. And again, vertex shader. The handle. This is the handle. Remember that. So okay. Next, we can't just compile the shader and then just hope it works, because this is actually the most sensitive part. So we actually really do have to do error checking here. So this is where it can get kind of verbose. So we're just going to store an int called status. And then there's something called GLGet shader IV. Here it takes in the shader, vertex shader, and it wants, and you have to specify which information it is we want to get. So we want to get the compile status, GL compile status. And then we have to give it the variable which we're going to store the status in, which will be status. Okay, and now we have to check if the status is successful. S status. Then if not status actually, then we'll create another variable called size. We have to get the error. They return the error as a complete string describing the error. So we actually have to create a string. We'll call it size. Next, we have to actually get the error itself, the length of the error. So GLGet shader IV again. The same thing, vertex shader. And then we'll use GL info log length. And then we'll actually give the variable to store the sizing, which will be size. And after we figure out the size, if you're using Visual Studio, you might not actually have support for this. But just for the sake of those people who may be using Visual Studio, we'll include vector. In code blocks, you could just create an array right there without doing any of that stuff. But you know what? I won't include vector. So actually, what we'll do here is we'll just create the variable on the heap. So char pointer shader log. We'll call it shader log equals to new char. I think that's the syntax for it. And then also every time we call new, we want to call delete as well. Delete with the array. Okay. Well, I can't remember the exact syntax. I think maybe the new thing, the thing goes here. We'll try it out and see. So yeah, that's what we're gonna do. And in between here, we're gonna printf the shader log. We're gonna get this info log. Sorry. So GLGet shader info. And then we're gonna pass in the shader, which again is vertex shader. And then the buffer size, which will be the size we just got. Then the pointer to the length, which is basically they want the memory address of the size as well. And then the actual variable we're going to store it in, so shader log. Okay. Next we need, in fact this is all. No, all we need to do is store it. All we need to do is print it to let us know what's wrong. So %s shader log. And let's also have a new line here. Okay. Now we need to do the exact same thing again for the fragment shader. So I think we should probably just copy most of this. And then just replace everything with fragment shader. I'm not too sure how to do find and replacing this. So we're just gonna do it. I'm just gonna do it by hand, but if you guys know you could do it, just find and replace everything below this point. And we have to change this to GL fragment as well. Okay, so let's just continue changing these. And again, fragment shader. So that's it. That's it for both of them. Now we just actually have to. So now we just have to link them and create a program. So to do that, we just create a program. We'll call it. Again, let's declare the variable out here. We'll call it shader program. So here, shader program equals GL create program. GL create program, and it doesn't take in anything. It just returns the handle to it. After we do that, we need to attach the shaders to it. So let's just do GL attach shader, and we pass the program that we want to attach it to, which is shader program. And the actual shader we want to use, we'll just use Vertex shader first. Doesn't really matter really. Then we'll attach another shader, which will be the fragment shader. So again, shader program, then fragment shader. So that's it. And then we just want to link the program. So GL link program, GL link program, and then we'll just link the program, shader program. Okay, and that's it. And then we want to do something called GL validate program. Okay, so we also want to do some error checking for the program itself. So here you go. It's kind of similar to this, except we just use, instead of use GLGet shader IV, we use GLGet program IV. So I'm tempted to even copy this entirely, but it may not work out. Also, we don't have to declare int status here again, so let's remove that. I'm tempted to just copy this. We'll just do it and see how it turns out. Right here on the link program, GLGet program IV. And instead of GL compile status, we want to get the link status and store it in the status. And if not status, then we'll just get the size, get program IV again. Okay, and again, instead of this, we'll just pass the shader program and get GL info log length. Nothing needs to change there. And then here, instead of this, we do GL get program IV. Get program info log. And I'm just going to change the name of this to program log. Same here. Doesn't really matter, but I'm just going to do it. Okay, so that should be it. If you have any errors, it will show up here. Okay, and the last thing you want to do is actually, well, not the last, well, you actually want to delete some of these things. So we could delete these shaders, because they're now on the GPU, just taking up space because we use them to link the program already, so we could just delete them. So we're going to delete the vertex shader, and we're going to delete the fragment shader. And then we'll use the program. So this is similar to binding, but it's not called bind for the case of a program. It's just called use. So GL use program, shader program. So again, as I mentioned, OpenGL is a state machine, so it will just use whatever shader is bound at the moment. So yeah, so we use this shader. We're not going to have any other shaders in this program, so we're just going to use this one. I'm going to bind it out here and then just never change it again. Okay, so that's it. So let's just run this and see what happens if it even compiles. Oh yeah, that's right. Let's put the semicolons here if you didn't. Okay, so spelling mistake. Again, semicolon. So maybe you actually have to put it after the char. I'm not sure. Did I put 4 in all of these? Oh shoot, it's supposed to be size. Let's just see if that fixes up. Oh yeah, so you do actually need to put it after the variable type. So size. And I also copy that same thing again. Size. So let's compile again and see. GLGet program IV was not declared in this code. GLGet program IV. Typo there. GLGet program info log. Shader log. Oh yeah, we're using program log. Okay. Okay, and this is supposed to be capital D in these cases here. Again, right here. Again, let's compile and run. Okay, and it seems we aren't using fragment shader source, so let's fix that. So in this, so where we're giving it the source, we have to pass fragment shader source. Okay, so let's run and see. The rectangle should be yellow now. If not, we did something wrong. Oh god. So it seems we're missing a semicolon or something in the fragment shader. Oh, I think it's because we didn't declare the type of this. This is a vec4. But the error wasn't too descriptive though. Okay, so as you can see now that worked. So next we're gonna go and get the texture set up. So in OpenGL there's something called a uniform. A uniform is basically something that's passed to the shader. So let's just declare the uniform down here. So uniform color of the texture. This is going to be the color of the texture. So we're going to sample the texture. So the variable for this is called a sampler 2D. And we're going to basically call it text. The name for it is a texel, the official name. So I'm going to use that. And then instead of just doing vec4, we can do texture. Texel. Oh yeah, I just remember we also need to pass out the texture coordinate. The texture coordinate we took in here in the vertex shader, we also have to pass that out to the thing. So this is how we pass variables between shaders. You have to say out. Well, in the case of the vertex shader, you can say out because this is the first thing in the pipeline. So whatever you output from here will go into the other stages of the shade or the pipeline. So out, and we're going to call this fragment text, or we're just going to call this vertex texture. So yeah, we're just declaring that it's going to be a out. It's going to be a vet2. Don't forget the type like I did. Okay, so in here we're just going to set this. So vertex texture equals to text coord, and that's that. Nothing more needed there. So in here we're going to take it in now. So in order to take in something, we just say in, and it has to have the same exact name. So let's just copy this to be sure. So in vector vertex texture, and in here in this texture function we have to pass in vertex texture. Just copy and paste it again. Okay, now this should actually work fine. Oh yeah, and spell texture correctly. Don't do like me. Okay, so this should work fine, but let's just see. We need to pass, and again I just explained what a uniform is. A uniform is something we pass from the C++ into the shader. So now let's just go link it. Remember, the shader is not running on the CPU, it's running on the GPU. So remember I talked about the texture slots. So we are using GL texture 0 here. So what this actually means is that the texture will have to, the sampler has to be assigned to texture slot 0. So that's what we'll do. So right here, right after we declare the image, we want to send the uniform. So the way how you send the uniform is you use GL uniform, and we're going to use one GL uniform 1i. We are sending one int. Depends on which type of uniform you want to send. There's many. There's for FV and those for vectors and stuff. But we only want to use one. We only want to send an int, so it's 1i. And then we have to use something called GLGet uniform location, because it's getting the location of this variable. Because remember, this is literally a program running on the GPU, so we're kind of like getting the memory address of it, and we have to actually pass the name in here. Texel, we call it Texel, so it has to be as that. And then the second parameter of this function here, not the GL uniform thing, GL location thing, we have to pass the value we want to set Texel to, which we'll set to 0. Okay, so that should be it actually. So let's just run compile and see what happens. Oh, sorry, actually we actually also have to pass in here in the uniform location. We actually have to pass in the shader program we want to use as well. So shader program. It made sense. I was wondering why it was. So I guess I just forgot it. So let's compile again. And as you can see, we're rendering the texture, but it's not rendering correctly. So I probably did something wrong. Let me go see. Okay guys, so I think I saw the problem. So apparently there is a problem with drawing like multiple objects, because before we were doing 2 triangles, but I think that was causing a problem. So I switched to just using, as you can see, we're only using 4 vertices, and so make sure you're drawing them in this same exact order I'm drawing it here. So copy this, like the order right here, and then also copy the order you have for the texture coordinate right here. And then when you're done, come down here to the where we draw the array, and use GL triangle strip instead. So this way we'll only be rendering one object. So let's see how this works. And as you can see, this is actually upside down. In the beginning they said let's just flip the image because OpenGL might have a problem, but it turns out it doesn't. So let's just remove this and do it again. And as you can see, it's working now. So yeah, sorry about the mishap there. I should have addressed that earlier. So now we have a texture rendering. And also you may have noticed that we just get a black thing, the black background here when the image has no color. This is actually supposed to be transparent, but it's black. If we want it to be transparent, we have to do something called blending. So we could do this pretty high up as soon as we initialize OpenGL. So yeah, we have it initialized right here. So let's enable blending. So first we have to do something called the blending function. And it basically, so this is the source, the S factor is the source. So we will just set it to GL source alpha. And then the destination, we just want to do 1 minus source alpha. 1 minus source alpha. Okay, and that should be that. So let's again compile and see if you want. But that's only if you want it to be like that. What's going on here? Oh, we did. Also, I forgot to. We have to enable it. So GL enable, GL blend. So yeah, that's what happens when you don't enable stuff. Okay, so that's it. So that's only if you don't want it to have a black background. But since we may be using this for like a video, it may not be that important. Also, I guess we could just make this the rectangle full screen now. Take out the full width and height. So let's just go change the texture coordinates from 0.5 to just 1. Okay, and be sure to comment out this thing. In fact, you could just remove these. I should probably remove these here. So yeah, let's make it full screen now. Okay, so it's now taking out the full screen. Because we're no blending, you won't be able to see it. So let's just disable blending for now. And this is it. But either way, yeah, that's it, guys, for this video. So now we have a texture rendering on the quad. So now, I guess from here, we could just work on making the server. So I think that's what I'll do next. Make the server, and then we'll get image data sent over the server. So we'll literally, so what we'll do is basically sending this image right here over on the network, and it will be a local server because guys, I tried to get peer-to-peer networking working once, but it just doesn't. I just cannot get it to work. So yeah, basically it will just be a local network for now. We'll have 2 instances of this program running, and then it'll just send the image over, and the other program will display. So yeah, that's it for this video, guys. See you guys next time.